How doing? All right, so we're going to talk about square roots and how to estimate speed. Yeah, this is a little random, but we're still talking about transportation and all that junk. So skid marks can be used to estimate the speed of a vehicle when drivers slam on their brakes. Pretty good. All right, road conditions. This is 4.3. Road conditions, the efficiency of the vehicle's braking system, and the speed of the vehicle all play a role in the length of the skid mark. If your brakes suck, you're not going to stop quick enough, right? So you need to make sure that your brakes are taken care of. Okay, that involves that maintenance piece. You do have to get your brakes. When should you get your brakes done? Not when they start squeaking, but
every year.
Every year you should probably have them checked, right? It depends on like how much you drive. And if you're one of those that like follow people bumper to bumper, which you shouldn't be doing in the first place. But if you do that, then you're more likely to be slamming on your brakes. All right, so we are going to fill in this table. Okay, so, all right. When we find the first difference, what does the word difference mean in math? Difference means subtraction. Okay, so we don't have a first difference for this first section, but what's 26 minus 0? Okay, what's 62 minus 26? All right, so pull out your calculator if you don't know.
36.
Okay. What is 108 minus 62? Okay. What is 164 minus 108? Okay. So do we see a pattern going on here?
It's got a 6.
Okay. So let's find the second difference. That means that we're going to subtract the first difference. So what's 36 minus 26? What is 46 minus 36? And what is 56 minus 46? Okay. Can we fill in that next part?
What were you doing for 15 minutes? I was like, yo, get out your packet, find your packet. What were you doing? Nothing.
I don't even have anything to keep alive.
Okay. I want you to like.
Okay. So how do we figure out if the speed is 50 miles per hour, how far that skid length is going to be? Well, if we see that there's a difference in 10 each time we're going up, then this difference should be 66, right? So what's 164 plus 66? 164 plus 66. 210. No, that's not right. 230. Okay. If we know that this difference is going to be 10, then this means that this guy is going to be 76, right? So what's 230 plus 76? Okay, so if you are going 60 miles per hour, you need 306 feet to stop. Okay, football players, how many feet is a football field? Feet. So how many yards? How many yards is in a football field?
123.
So there's 100 yards in a football field. Each yard is about 3-ish feet, so about 300 feet. You need a football field length if you are going 60 miles per hour to stop. Yes, you do. Are you sure? You want to go test it? Go test it.
This is like
No, this is hard braking.
Get fast as you've ever gone.
180 miles per hour.
What? Wait,
Hold on. All right. So bring it back. If the second differences are the same, then that means that this is what type of function? No. Linear would be the first difference is the same. Quadratic, y'all having side conversations that aren't math. So quadratic means that the second difference is the same, okay? If the first difference is the same, that's when it's going to be linear, okay? Yep. All right, now we're going to graph the data points. So we are going to use the speed, okay, and the skid length in feet to graph this guy. So what's going to be our first point? It's going to be our first point from that table. 0, 0. Okay, so go ahead and put a dot at 0, 0. What's the next point?
And 26.
Okay, so go ahead and put a dot at 10, 26. And these should be by 50, 100, 150, 200, because otherwise it's not going to work. Go ahead and just increase that by 0. Okay, so if you have a skid length of 26, but then you have a speed of 10, that's going to look like this. Okay. And let's actually, hey, before you start graphing it too far, let's change these to like a smaller amount.
So what would change the number?
So we change these to 50, 100, 150, 200, etc. On this side, I want you to change these to 20, 40, 60. Okay. All right, so let's go ahead and plot. And so that's going to be 26, comma 10. That's going to be right about there. The next one is 20, 62. So we're going to go to 62, go up to 20. And the next one, 30, 108. The next one, 40, 164. The next one is 230 and 50. And then the next one is 306 and 60. Okay, when you connect that, what's the what? The second dot, look at your table. It's 26, comma 10. 26, comma 10. Okay, so really quick, this is in the shape of what we call a square root function. Okay, this is the inverse function for a quadratic. Okay, so just a refresher, quadratic looks like this. A square root function looks like this. Those are inverses of each other. If you don't remember that, write that down. Okay. So now we're going to take a look at the formula behind this. Okay. And it is a square root function for the formula. Here it is. It's S equals the square root of 30 times D times F. I'm going to give that to you. You need to know what D and F stand for. You need to know what S stands for. So S represents the speed, D is the distance, and F is the coefficient of friction. Okay, so we know what friction is? Throw back to physics. Yeah, what is friction?
Contact.
Okay, so contact. So like as you are trying to stop you rolling forward, there is a contact that happens, right? So there is also a drag that happens. Okay. Just for your information, an icy road has a drag factor of about 0.1. Dry concrete would result in a drag factor of 1.2. Okay. Good. All right. So let's go ahead and start looking at some problems. Okay, so example 1. An accident has occurred. Law enforcement investigators are trying to determine if speeding was a factor in the cause of the accident. The length of the skid mark of the car involved is 20 feet. Based on the weather and the car's braking system, the drag factor is determined to be 1.3 grams. Okay. Approximately how fast was the car traveling when it entered the skid? So what's our formula? It's S equals the square root of 30 times D times F. Okay. What was our speed? Do we know that? No, that's what we're trying to find. We're trying to find how fast it was going. Okay, so S equals, do we know what the distance was? 20 feet. And do we know what the drag factor was? So all you're going to do is you're going to type this into your calculator. Take a second, do that. If you don't know how to type it into Desmos, you can use the keyboard to get the square root, or you can type in SQRT, and that does the square root as well. So go ahead and take a moment, type this in. Yep. So we get 27.93, and that's miles per hour. Biggest thing in this section is making sure that you use your units. Okay. Was that bad? Girl. Okay. Looking at the graphs below, they represent the same car entering a skid with a given speed under the two different weather conditions. Which graph most likely represents icy conditions? Which graph represents mostly icy conditions? Okay, so as we increase our speed on this one, as we increase our speed, the distance expands, right? Okay, so we only get up to about 25 miles per hour. Think about it. If you're on icy road, right? And you're driving just 15 miles per hour, even if you stop, doesn't your car continue on and it kind of slides a little bit more? Think about dry conditions. If you're driving your car and you try to stop, you're gonna stop a little bit quicker, right? Okay, so graph A is going to represent icy conditions. Okay, lower speed, you skid further. Okay, so looking at this again, we're only at 25 miles per hour and it's taking us 100 feet to stop. Yeah. By the way, how many of y'all, this is a bad question. How many of y'all have ever been in a car accident? Okay, that's good. Okay, good. I'm glad that it's not a big group. But that being said, if you ever get in an accident, do not move your car unless it is in like if you're gonna get hurt by sitting there, then move your car. But do not move your car until you take pictures. You want to take pictures of your car, so the damage. You want to take pictures of any skid marks. So if somebody like rear ends you or you brake because you weren't paying attention, you need to take a picture of the skid marks. Yeah. Okay. The police will also come out and kind of assess it, but make sure that you take pictures of everything, not just your car, the other car as well. Yes. Okay. Like no picture, like you can't take too many pictures. Take all the pictures you can. Okay. Number 3, an automobile accident has occurred. A local law enforcement agent has determined that at the time of the accident, road conditions resulted in a coefficient of friction of approximately 1.1. If the police officer determines that the car skidded for 58 feet, how fast was the vehicle traveling when the officer forcibly applied the brakes? Okay, let's try this. What is the formula? S equals the square root of 30 times D times F. Okay, we're trying to figure out how fast the car was going, right? So we don't know what S is, what's their distance, 58, and what was our coefficient? Okay, take a moment, plug that into your calculator. All right, so I got 43.75 miles per hour. Okay. Everybody good? Not too bad, right? Okay, go ahead and flip the page. All right, two cars are traveling on the same road at the same time. Car A has a drag factor of 1.2 and hits the brakes of skid 60 feet. Car B has a drag factor of 1.1, hits the brake to skid 61 feet. Which car is traveling faster? Okay, so we notice that there is a difference in the drag. We also see that there's a 1 foot difference between the feet, right? So let's do car A first. Remember, our formula is the square root of 30 times D times F. So when I plug in, that's going to be 30 times 60 times 1.2. Type that in. Tell me what you get. What'd you get? That's 60. No, that's for car A.
Oh,
Yeah, that's car B. So when we plug this in, we're going to get 46.48 miles per hour. Can you do car B? Find how fast car B was going. Less? I hate when you sneeze and it like hurts your whole soul. Y'all know what I'm talking about. All right, when you plug that in, I got 44.87. Who was going faster? Car A was going faster. Cool. Again, not too bad, right? All right, so other business applications with square roots. So you're trying to rent a warehouse for your business. An ad for a warehouse claims the area is a perfect square and it has 625 square feet. You want to place shelves along one wall of the warehouse. If each shelf is 5 feet long, how many shelves will you be able to fit? So again, a little random, but understanding the application of square root. So really quick, a perfect square, throw back to algebra 1, you would have x squared equals 625. Okay, this is, if you have a square, the side length is x, the other side is also x. When we have area, that is length times width, right? Area is length times width. So if I want to figure out what x is, I'm going to take the square root of both sides. So what's the length of one side? 25. Okay, now let's go back to what the question was asking. You want to place shelves along one wall, and each shelf is 5 feet long. So if I have 25 feet for one length, and each shelf is 5, how many can I fit? I can fit 5 shelves. Everybody got it?
So we divided it.
Yes, because each shelf is 5 feet. Then we're trying to figure out how many we have. Again, a little random, but that's okay. I had to do that the other day. I said the other day, yesterday, I had to put pine straw out. And I had to figure out the cubic feet of how much pine straw is one bale, and then measure how far my little like flower bed thing is. Sucked. It's terrible. But I didn't want to overpay. So I also didn't realize how expensive pine straw was. Yeah. The little annoying pine needles that you always get on your shoes. That's it. All right. So you have a business and you suspect you are receiving diminishing returns. What does diminishing returns mean? Diminishing returns. Mm.
But it's not accepted, like they don't really.
Mm, no. So diminishing returns, well, when we talk about profits, that's how much money we're making, right? Diminishing returns, does that sound like a good thing or a bad thing? Bad thing. You're not getting as much profit. No, returns means what you're getting back.
You return something and they give you less money than you bought it for.
No. Okay, so when we are talking about returns, that means how much money you are getting. Returns for your profits, that's how much money you're getting. If I say diminishing, that means that it's going down. You're not getting as much profit. Returns is just what we say when we're like getting the money to us. Yeah. Okay. So your profits for August, September, October, and November are listed below. Okay, so do you see here we got 46,000, I'm sorry, 4,600, then 48.79, 51.43, and then 53.94. If the function is a square root function, then the situation models diminishing returns. Are your suspicions correct? So we want to find if it is got a second difference that is the same. Okay, so let's find the first difference. Coming down here, just kind of add like a little row. So we don't have anything to compare this one to, but what is 48.79 minus 4,600?
279.
279. Okay. What is 51.43 minus 48.79? Okay. And then what is 53.94 minus 51.43? Okay. Now, the first difference is not the same, so it's not a linear function. Let's go ahead and look at the second difference. Okay, second difference is where you're going to take the first differences and subtract them. Oh, we can't do it for this one. Can't do it for this one because we don't have anything to compare it to. What is 264 minus 279? 264 minus 279. Negative 15. What is 251 minus 264? Okay, negative 13. Are these two numbers the same? No. Okay. So are they close though?
Yes.
They're pretty close. Okay, let me give you a little bit more info. What if I made this be December? 5, 6, 3, 1, 2, 7, I'm sorry, 2, 37, and negative 14. Are these numbers pretty close? Okay, so yes, your suspicions are correct because the second difference are pretty close. Okay, so again, you want it to be pretty close. This would be our projection for December because these numbers want to be very similar, very close together. Okay, go ahead and look at number 3. Go ahead and read that over. So you've been hired as a researcher for a major car company to calculate the coefficient of friction for their newest truck. You drive the truck and hit the brakes at 50 miles per hour, measure the skid marks, and the results are below. So in the first trial, you had 36 feet worth of skid mark. Second trial, 42. Third, this should be 3. Oh, why that's like that. And then 38, then 40. Use the average skid length to calculate the truck's drag factor. Okay, first of all, how do we figure out the average skid length? How do you find the average? Right, so we're going to do 36 plus 42 plus 38 plus 40, and then divide by 4. So 36 plus 42 plus 38 plus 40, and then you're going to divide by 4. Tell me what your average is. 39. Okay, so the average is 39. Okay, so now we're trying to find the drag factor. Go back to our formula. S equals the square root of 30 times D times F. We know that our speed is 50 miles per hour. We know that our distance is 39. And we're trying to solve for F. Okay. So, remember how I feel about having to solve things. You can use Desmos for this, but I'm going to also show you the handheld way. Okay. You can type this into Desmos and just put X for that F and then look at where it crosses the X axis. But if you were having to do this by hand, you got to get rid of the square root first. So you're going to square both sides. And that's going to give me 2,500 on the left. On the right, if we multiply 30 times 39, that's going to give us 1,170 times F. And then if we want F by itself, we're going to divide by 1,170, which is going to give us a drag factor of 2.1. Again, if you're not about the whole like solving it by hand thing, yes, you can use Desmos. Make sure that you put X instead of F. Okay. If you want to check that, you can type in 50 equals the square root of 30 times 39 times X into Desmos and see that it crosses at 2.1.